Ah, we're back again. Unfortunately, we're not in VR today. It's quite sad. I've had some technical difficulties. So unfortunately, we're gonna have to do this in MS Paint. Sorry. And also, since this is MS Paint, it's kind of hard to write in. So I've already have all the answers kind of out and about, and I'm just gonna explain how we find them. Um, So we're doing problem 5.1.5 right now, and problem 5.1.5 is basically we're given told some values about a graph v which is of course the derivative of what we want of the graph of s of t. Um, So we're given that A1 is equal to about 776, and that A2 is equal to about 886. And then we're asked to find, of course, what S1, S3, S5, and S6 are. So in order to do this for S1, it also helped to know that we have S of t at 0, or S of at 0 is equal to 1/2. So we know that A1, which is the first kind of sector or portion, area under the curve of VT, is equal to 7/6. So we know that entire area. So what we can find is basically area under the curve from 0 to 176, but we also have uh, s of 0 is equal to 0.5. So basically what we do is we kind of just take 7/6 and then add 0.5 to that from the starting value of the function st, and then we get 5/3 for that. S3, what we have here is we're looking at the value of A2 now. A2 is 8/3, or 2 point, or sorry, no, yeah, it's 8/3, 2.16. But it's in the negative, so we got to first subtract the 0.5, which is starting value of S0, and then we get down to 2.16. Sorry, I know fractions might have been helpful, but I can't do them in my head. And then we subtract the 7/6, which is the positive value, from V0 to VT, which is A1, and we subtract that from A2 as well, and then we're left with -1, which is the value of what ST would be at uh, at 3, basically. And then S5. So what we do with S5 is, of course, we got to kind of add the 8/3 onto itself again because it's still in the negative. Then we got to subtract the 5, and then, or the 0.5, and the and the 7/6 from A1, and then we should be left with -11/3. And S6 is primarily the same way, although we get left with a much smaller number, so that we see that when we graph it here at the very bottom, you can see my cursor down here, it'll start increasing at that value. So B, what we're asked to find is where is ST increasing and where is it ST decreasing. Well, it is decreasing from 0 to 1, or it is increasing, sorry, from 0 to 1, and from 5 to 6, because on the graph VT, 0 to 1 and from 5 to 6 are where the graph is positive, and then is decreasing from 1 to 5, which is where the graph is negative. And C, we're asked to find the concaves. It is concave down when t is less than 2. That is because if you look at the graph is decreasing to a negative slope and is concave up when t is greater than 2, because it is then increasing from that slope. So we see that concave. And then D, it says with information we got from A, just to graph it. So we're graphing it down here like this, all nice and pretty. And then E, sorry for the messy handwriting, but E says to find the equation, or I guess the original equation of S of t given the derivative Vt. And so basically the derivative Vt is -2 plus, that t kind of melted into there. So there should be an extra t in here. So Vt is -2 plus 1/2 t minus 3 squared, and that's all of Vt. And in order to find the integral of that, basically what we do, we know that if -2 is by itself, that means of course it would have had t on it, so we get -2t there, and then we know that t minus 3 is squared right here. So in via t, and so if it's been differentiated, there you go, something like that. We know that it drops the power and brings that power to the front. So we have to undo that, which is why we get that half, because it brought it down by 1 and put the 3 out here, which is why we got 1/2. And then if we got to undo that, we of course divide 1/2 by 3, we get 1/6, and then we put that power back up here. But we're not done, because you've got to see if we have a constant. So what we can do then is we take what we have, the 2t plus 1/6 times the t minus 3 cubed, and then we take a value from A, or one of our values that we found in A. So I used 3. So if we know that 3 is supposed to equal -1, you plug -1 in here, and we got to find that our leftover constant is equal to 5. So, which is pretty cool. As a reflection, I know that this kind of sucks. I really should have planned for this, but I didn't know that my computer didn't have a display port. So sorry about that. I hope to do better next time, and sorry about the MS Paint. I know it could have been a little bit better, and my explaining could have also been a whole lot better. But thanks, and have a good one.